Hey everyone, ready for another deep dive. Today we're taking on a topic that's, well, kind of taken over the world. Large language models, LLMs.
Yeah, they're everywhere now.
I mean, you send us a ton of stuff about them, even excerpts from this guide, LLM from scratch. And it got me thinking, like, how do those super smart chatbots, or even just my phone knowing what I'm about to type, how does that even work?
It really is mind-blowing how integrated they are.
So this guide, it starts off simple.
Yeah.
An LLM is, and I quote, a statistical tool predicting the probability of a sequence of words.
Right. Sounds a little jargony.
Okay, yeah, a bit technical, but think of it like this. It's what's behind your phone guessing your next text, or those chatbots that are so good you almost think they're human.
And the thing is, it's not magic. It's the culmination of, decades of work. The evolution of LLMs is fascinating.
So, like, where did it all begin? Where'd they start?
Well, early on, we had things like n-grams. They analyzed chunks of words, but they couldn't really grasp the wider context. Imagine trying to figure out the ending of a movie just from the last 5 minutes.
Yeah, you'd miss a lot.
You'd miss the plot, the character development, everything. Context is key.
So how did LLMs get smarter then? Like, how'd they evolve to understand more?
Think of it as adding layers of understanding. We went from those basic n-grams to hidden Markov models. These started to consider, underlying patterns and probabilities in language.
Okay, so they got a bit more sophisticated.
Right. And then came recurrent neural networks, or RNNs. These could deal with much longer sequences, like entire sentences. But even RNNs struggle to remember information from way earlier in the text.
So like a short attention span.
Exactly. They couldn't quite hold on to the long-term context.
So what changed that? How did they fix that problem?
That's when LSTMs came in. Long short-term memory networks. Pretty descriptive name, right?
Yeah, I get it. Long-term memory.
Exactly. They were designed with these memory cells. Think of it like a computer storing vital information for later.
Makes sense. So they could finally handle those longer connections in language.
Yes. And that was a huge leap forward for things like, speech recognition, where a sentence can go on and on.
Oh, right. So like for those voice assistants, it needs to remember what you said at the beginning, even if you're giving it a whole list of commands.
Precisely. And then there are GRUs, gated recurrent units.
Yeah, I saw those mentioned in the guide. Are those in the same family as LSTMs?
Sort of, yeah. Think of them as a more streamlined, efficient version of LSTMs. Still really good at handling those dependencies in language, but maybe a bit less computationally intensive.
Oh, so like a more compact, energy-saving model.
You got it. You often see GRUs in things like chatbots, where remembering the conversation flow is key.
That makes sense. So we've gone from those simple word chunks to these memory-powered models, but this guide, it jumps to transformers next, which seem to be like the big deal now. What makes them so different, so special?
Transformers, they really did revolutionize things. It's all about attention. Remember how we talked about LLMs needing context?
Yeah, to really understand what's going on.
Right. Well, attention allows them to focus on the most important parts of the input, just like we do when we're reading or listening.
Okay, so it's not just processing each word one by one. It's more like how we think, grasping the whole meaning.
Exactly. That's self-attention. The ability to understand the relationships between words, even if they're far apart in the sentence.
So it's like they can get the whole picture, like our brains do. And this is the tech behind those mind-blowing models like GPT-3.
You got it. GPT-3 from OpenAI is like the poster child for how powerful transformers can be.
Yeah.
It's not just predicting words. It can write different creative content, translate languages, even code.
I've seen some of the stuff it generates. It's pretty wild.
It's really pushing the boundaries of what's possible.
But before we get too carried away with all the cool stuff LLMs can do, this guide takes us back to the less glamorous part, the math.
The foundation.
Yeah, it talks about probability, statistics, information theory, linear algebra. It's a bit intimidating, but I promise we'll try to keep it light.
We'll extract the good stuff.
Exactly. No need to get lost in equations. But it is interesting to see how these powerful models are built on those fundamental concepts.
Absolutely. Like probability, for example. That helps LLMs deal with the uncertainty in language. I mean, there are so many ways to finish a sentence, each with a different likelihood.
Right, like the model's got to figure out which one is the most likely, the most sensible.
And then there's statistics. That's what lets LLMs find those patterns in massive amounts of data.
So, like figuring out how often certain words appear together. Right.
Exactly. It's
Yeah.
all about finding those connections, those relationships between words.
Okay, that makes sense. And what about information theory? Where does that fit in?
Information theory is about efficiency. Think of it like packing a suitcase for a trip.
Okay, I'm visualizing.
You want to fit as much as possible, right? But you also don't want to waste space.
Yeah, you want to be strategic about it.
Exactly. Information theory helps LLMs represent data in the most compact, efficient way possible.
I love that analogy. So it's like finding the optimal packing strategy for information.
Precisely. And finally, we have linear algebra.
Ah, yes, the one that brings back those high school math nightmares.
Don't worry, we won't get too deep into the weeds. Think of linear algebra as a way of translating words into a language that the LLM can understand. It represents words as vectors, which are like coordinates in a multidimensional space.
Okay, so it's like giving each word a unique location in this vast space of meaning.
Exactly. This allows the LLM to perform calculations and find relationships between words, even if they're not right next to each other.
So it's not just about the order of words, it's about their meaning and how they relate to each other in this abstract space.
That's a correct way to put it.
It's amazing how all this math comes together to create such creative and intelligent systems. But the guide, it doesn't stop there. It dives into those building blocks of LLMs like neural networks, which seem to be inspired by the brain.
It's a fascinating area. Neural networks are like the engines that power these LLMs. And they're different types, each suited for different tasks.
Right, like convolutional neural networks, CNNs, which I know are used for image recognition. Those are what power those medical diagnosis tools that can spot patterns in X-rays, right?
Exactly. CNNs are incredible at extracting features and patterns from visual data.
So they're like the visual experts of the AI world.
And then, of course, we have our old friends, the recurrent neural networks, RNNs, which are perfect for sequential data like text. They're behind things like language translation, speech recognition.
Anything where the order of words matters.
Precisely.
And then there are those sci-fi sounding generative adversarial networks, or GANs. Those are the ones where two networks are like battling it out to create something new, right?
You got it. It's like an AI arms race. One network tries to generate realistic data, while the other tries to spot the fakes. This competition pushes both networks to get better and better.
It's like AI playing a game of cat and mouse, pushing the boundaries of creativity.
And the results are incredible. JNs are used to create realistic images, music, even videos.
It's mind-blowing. But within these neural networks, there are even more moving parts. The guide mentions activation functions and optimization. Can you break those down for us?
Sure, activation functions, think of those as like little decision makers within the network. They decide which neurons should fire or become active based on the input.
So they're like gatekeepers controlling the flow of information through the network.
Exactly. And they introduce a level of nonlinearity that allows LLMs to model the complexities of language.
Okay, that makes sense. And what about optimization?
Optimization is like fine-tuning a musical instrument to get the perfect sound. It's about adjusting the parameters of the LLM, its internal settings, so that it performs as accurately as possible.
So it's like having a virtual tuner constantly tweaking the model to get the best performance.
Precisely. And there are various algorithms like gradient descent that help us find those optimal settings.
Okay, so it's not just about building the model, it's also about fine-tuning it to make sure it's working at its best.
Exactly. It's a crucial part of the process. And speaking of processes, let's circle back to those sequence models, specifically RNNs, LSTMs, and GRUs. Remember how we talked about them being good at handling sequential data, which is so important for language?
Yeah, like language flows, it's not just a bunch of random words thrown together.
Right. And RNNs, they have this hidden state that carries information from previous words. It's like reading a book, you understand each chapter better because you remember what happened in the previous ones.
It's like having a mental bookmark, keeping track of the context.
Exactly. But remember, those standard RNNs, they can struggle with long-term dependencies, remembering things from way back. That's where LSTMs and GRUs shine, with their special memory cells.
Ah, right, they're the long-distance runners of language processing.
Precisely. They can keep track of those longer connections in language, which is crucial for things like understanding a long speech or a complex conversation.
Makes sense. And then there's self-attention, which the guide says is key to how LLMs understand the relationships between words. Can you explain that in a way that, well, someone who's not a computer scientist can understand?
Sure. Imagine reading a sentence where the verb is at the very end, but you still understand what's going on. Your brain is making those connections between the subject, the object, and the verb, no matter where they are in the sentence.
Oh, right. Like our brains are good at figuring out those relationships, even if the grammar is a bit unusual.
Exactly. That's what self-attention does for LLMs. It lets them see those connections between words, regardless of their distance.
So it's like having a mental map of the sentence where the LLM can see all the connections at once.
Precisely. And that's where transformers come in. They rely heavily on self-attention to process language in a more sophisticated way.
So they're like the next level up from those RNNs, LSTMs, and GRUs.
Exactly. Instead of processing words one by one, they can analyze the whole sentence simultaneously, thanks to self-attention. They also use a feed-forward network that processes each word individually, along with positional encoding, which tells the model where each word is in the sentence.
So it's like they can see the whole forest, and each individual tree at the same time. And the guide mentions this encoder-decoder framework that transformers use, especially for things like translation. What's that all about?
It's a two-step process. Imagine you're translating a sentence from English to, say, Spanish. The encoder takes that English sentence and compresses its meaning into a compact code. Then, the decoder takes that code and uses it to generate the Spanish translation.
Oh, so it's like distilling the essence of the sentence and then rebuilding it in another language.
Exactly. It's a very elegant and effective approach.
And what about multi-head attention? I remember we talked about that earlier. How does that fit into the whole transformer architecture?
Multi-head attention is like having a team of experts, each analyzing the sentence from a different perspective. Instead of relying on one attention mechanism, transformers use multiple, capturing different aspects of the relationships between words.
So it's like getting a second, third, even fourth opinion on the sentence to make sure you're really understanding it from all angles.
Precisely. It gives the model a much richer and more nuanced understanding of the language.
It's amazing how all these complex components work together. But building these models, it's not just about the algorithms, right? It also requires some serious computing power. This guide talks about the infrastructure behind LLM training, and it sounds pretty intense.
It is. We're talking massive data centers filled with powerful computers, specifically GPUs or TPUs, which are designed for handling those huge calculations involved in training these models.
It's like an LLM gym, where they're constantly working out, getting stronger.
That's a great way to put it. And it's not just about the hardware. The software is crucial too. The guide mentions frameworks like TensorFlow and PyTorch.
Yeah, what do those do exactly? I've heard those names thrown around a lot.
They're like the construction crews and project managers of the LLM world. They provide the tools and building blocks for creating, training, and deploying these models. They handle things like distributing the workload across multiple computers so the training goes faster, and they make sure everything runs smoothly.
So they're like the logistical masterminds behind the scenes, making sure everything works together seamlessly.
Exactly. But even with all the right tools, you need the right ingredients. And in the world of LLMs, that's data. Lots and lots of data.
Right, these models are trained on massive data sets. I mean, we're talking billions of words, right?
Absolutely. Data is the fuel that powers these LLMs.
Yeah.
And managing all that data, processing it efficiently, it's a huge challenge.
It's like feeding a hungry giant. You need a well-organized kitchen and a steady supply of ingredients to keep it satisfied.
That's a great analogy. And speaking of pushing the boundaries, this guide goes beyond those basic LLM architectures and dives into some really advanced stuff like sparse models and attention variants. What are those all about?
Yeah, I was curious about that too. It sounds pretty cutting edge.
Sparse models, like the mixture of experts approach, they're all about efficiency. Instead of using every part of the network for every task, they only activate the parts that are most relevant.
Oh, so it's like having a team of specialists. You call in the expert who's best suited for the job rather than having everyone work on everything.
Exactly. It's a much more efficient use of resources.
Makes sense. And what about those attention variants?
Well, traditional self-attention can get pretty computationally expensive, especially with those really long sequences of text. So attention variants, they try to make it more efficient without sacrificing accuracy.
So like finding shortcuts that still get you to the right destination.
Exactly. And then we have multimodal LLMs, which can handle different types of data like text, images, audio, all in one model.
Those are the ones that really seem like science fiction almost.
They are pretty incredible. They have the potential to revolutionize how we interact with information. Imagine a search engine that could find not just text, but also images, videos, audio recordings, related to your query.
Or a virtual assistant that could seamlessly switch between different modes of communication, understanding your spoken commands, and responding with both spoken and written language.
Exactly. We're moving towards this world where AI can truly understand and interact with the world in all its complexity.
It's pretty exciting, but with all this power comes responsibility, right? I mean, building these complex models, that's just the first step. We also need to make sure they perform well and that they're used ethically. And that brings us to the topic of hyperparameter tuning, which sounds pretty important.
Hyperparameter tuning is crucial. It's like finding the perfect recipe for a delicious cake. You experiment with different ingredients, oven temperatures, baking times, until you find the combination that yields the most delicious result.
Okay, so it's like fine-tuning the LLM recipe to get the best results.
Exactly. And in the world of LLMs, those ingredients are the hyperparameters, the settings that control how the model learns.
So it's about tweaking those settings to get the best performance out of the model. And this guide, it mentions a whole bunch of techniques for hyperparameter tuning, from simple things like grid searches to more complex methods like Bayesian optimization. Can you give us a quick overview of what those are all about?
Sure. Grid search is like trying every possible combination of settings one by one. It's thorough, but it can take a long time, especially with those complex models. Random search, on the other hand, is more like throwing darts at a dartboard and seeing what sticks.
Yeah.
It's less systematic, but it can be surprisingly effective.
So grid search is methodical, while random search is more adventurous.
That's a good way to put it.
Yeah.
And then we have Bayesian optimization, which is a more strategic approach. It uses a probabilistic model to learn from previous trials and focus on the most promising areas of the parameter space.
So it's like having a smart assistant that helps you navigate this vast landscape of hyperparameters.
Exactly. And then there's population-based training, or PBT, which is like Turn-in for LLMs. You train a bunch of models with different settings and let them compete.
Survival of the fittest for algorithms.
Precisely. And the best performing models, they get to reproduce, passing on their settings to the next generation. It's a clever way to let the models learn from each other and evolve over time.
It's like evolution in action, but for AI. And then the guide mentions these adaptive learning rate schedules, which sound pretty important for keeping the training process on track.
They are. Think of them like a dynamic cruise control for the training process. They automatically adjust the learning rate, which controls how quickly the model learns, based on how well it's doing.
So it's like finding that sweet spot, not too fast, not too slow, just the right pace for optimal learning.
That's a great way to think about it.
Yeah.
And to top it off, we have automated hyperparameter tuning, or AutoML, which is basically like having a team of robots working tirelessly to find the best settings for your LLM.
That sounds amazing, like having a personal assistant for your LLM taking care of all the tedious detail.
Exactly. And these AutoML frameworks are becoming increasingly sophisticated, freeing up human experts for more creative and strategic tasks.
Okay, so we've covered a lot of ground here, from those fundamental building blocks of LLMs to all the advanced techniques used to train and optimize them. But I think it's time to move on to the really exciting part. How are these incredible models actually being used to solve real-world problems?
I'm excited to dive into those applications too. The guide provides some really fascinating case studies from various industries.
I can't wait to explore them.
Let's jump into some of those real-world examples then. This guide kicks things off with the Mayo Clinic and how they're using LLMs to help doctors with something, well, pretty crucial: diagnosing diseases.
Oh, wow. Yeah. High stakes. I mean, I know even the best doctors can miss things, especially with rare conditions, or just like the sheer volume of information they have to deal with.
It's true. It's like trying to solve a giant puzzle, but the pieces are all medical jargon and symptoms.
And the clock is ticking.
Exactly. So that's where LLMs come in. The Mayo Clinic, they actually teamed up with Google Health to create a system that can assist doctors with diagnosis.
Like an AI consultant.
Pretty much. They train this LLM on a mountain of medical knowledge, research papers, clinical notes, you name it.
So it's got all that expertise at its fingertips. But what about patient privacy? I mean, that's a huge concern with medical data, right?
Huge, yeah. And the Mayo Clinic was very aware of that. They made sure to de-identify all the data used to train the LLM.
So like no names or anything that could link back to a specific person?
Right. The model learns from those patterns in the data without ever knowing who the patients are.
Okay, that makes sense. So it's learning from the collective wisdom of all that medical knowledge without compromising anyone's privacy. But medical language, that can be super complex, right? All that jargon and technical terms. How do they make sure the LLM could understand all that?
They basically gave it a crash course in medical school. The team fine-tuned the model specifically for medical language, teaching it to recognize those subtle differences
Right.
between all those medical terms and concepts.
So they taught it to speak doctor, basically.
Exactly. And it sounds like it's working. A guide says this system has actually reduced diagnostic time and improved accuracy.
That's huge. I mean, that's a win for everyone, right? Faster diagnoses, more accurate treatment.
Absolutely. It's a great example of how LLMs can really augment human expertise and lead to better outcomes.
Okay, I'm ready for another industry shakeup. What's next?
Let's switch gears to telecommunications. This case study focuses on Vodafone, the global company, and how they used LLMs to, well, revamp their customer service.
Oh, I'm all ears. I think we've all had those frustrating experiences with chatbots that just don't get it. You know, those endless loops where you just want to scream, operator, human, please.
Yeah, those simple rule-based chatbots, they can be a nightmare. Too rigid, no nuance. So Vodafone, they decided to try something different. A fine-tuned LLM that could actually understand and respond to customers effectively.
So they brought in the LLM big guns?
Pretty much. And they trained this LLM on their own data, their customer support logs. So it learned from all those past interactions.
Oh, that's smart. Like giving it a crash course in Vodafone Customer Service 101.
Exactly. But customer interactions, they can be messy. People use slang, misspell things, get frustrated.
Yeah, real world language, not textbook stuff.
Right. But that's one of the advantages of LLMs over those simpler chatbots. They're much more flexible and adaptable. Plus, Vodafone took it a step further. They incorporated sentiment analysis.
Okay, what's that? Does the LLM like read people's minds now?
Not quite. Sentiment analysis, it lets the LLM detect the customer's emotional state based on their language. So if someone's angry, the LLM can adjust its tone or even escalate the issue to a human agent.
Oh, wow, that's smart. So it's like the LLM has emotional intelligence.
In a way, yeah. It can sense when a situation needs that human touch. And the results. Vodafone saw a big drop in call volume and a boost in customer satisfaction.
So it's a win for everyone. Again, customers are happier and the company's more efficient.
Exactly. Okay, ready for another one? This one takes us to Wall Street, high finance. We're talking Goldman Sachs and how they're using LLMs to analyze the financial markets.
Bring on the stock market algorithms, but seriously, how does that even work? I mean, those markets move so fast, so much data.
It's overwhelming, even for the experts. Trying to keep up with all the news, the reports, social media, it's impossible. So Goldman Sachs, they brought in the LLMs, trained one on a massive data set of financial data news, company filings, historical trends, everything.
So it's like having a team of super analysts working 24/7.
Exactly. It can monitor way more information than a human, and it can spot those patterns and signals that might be missed. But of
Yep.
course, you have to make sure the LLM is getting reliable info. There's so much misinformation out there, especially on social media.
Yeah, the LLM is only as good as the data it's fed.
Right, so Goldman Sachs, they had to be very careful about that data curation, making sure it came from trustworthy sources. They also put systems in place to cross-check info and flag any inconsistencies.
So like a fact-checking department for the LLM.
Pretty much. But
Yeah.
even with good data, financial language can be tricky. It's got its own jargon.
Wall Street speak.
Right, so they actually built a domain-specific knowledge base into the LLM, like giving it a glossary of financial terms.
So it could speak fluent finance. Did it work? Did it give Goldman Sachs an edge?
Definitely. It
Yeah.
helped them make faster, more informed decisions, which is crucial in that world.
Makes sense. Time is money. Okay, from Wall Street to Hollywood, I guess. This next one is about Netflix and how they're using LLMs to help with, wait for it, script writing.
Yeah. It's interesting because it shows how LLMs can support human creativity, not replace it.
That's always the big fear, right?
Yeah.
The robots are going to take over Hollywood.
Right. But Netflix, they saw LLMs as a tool for their writers. They fine-tuned a model, one of those GPT-style ones, on tons of scripts, TV episodes, even books. So it learned the structure of narratives, dialogue, all that.
So it's like giving the LLM a masterclass in storytelling.
Exactly. But of course, you don't want the LLM just copying existing stories, right?
Yeah.
You want originality.
Plagiarism is bad, even for AI.
Right. So Netflix, they implemented something called creative filtering. It's like a plagiarism detector built into the LLM. If it generates something too similar to existing stuff, it gets flagged.
So the LLM can help writers with ideas, dialogue, even writer's block, but it won't just churn out copies.
Precisely. And it's not just about avoiding plagiarism, it's about pushing those creative boundaries. The LLM can introduce writers to new ideas, new perspectives.
It's like having an AI brainstorming buddy.
That's a great way to put it. And the writers seem to like it. It's making them more productive, giving them more time to focus on the high-level creative stuff.
That's awesome. I love that using technology to enhance human creativity, not stifle it. Okay, last one, right? From Hollywood to the courtroom.
Yep. Last but not least, this one's about Allen and Overy, a global law firm, and how they're using LLMs for something that lawyers are, well, not exactly known for loving, legal document review.
I can imagine. Those documents are dense, full of jargon. Must take forever to read through them all.
It does, and accuracy is crucial, but it's easy to miss things, to misinterpret something. So Allen and Overy, they trained an LLM on a massive database of legal documents, case law, contracts, all that.
So they taught it to speak legalese.
Exactly. Now, the LLM can understand all that terminology, identify key clauses, even assess risks. It can also summarize those lengthy documents, saving lawyers tons of time.
That's incredible. It's like having an AI paralegal.
Right. But it's important to emphasize it's not about replacing lawyers. It's a tool to help them be more efficient, more accurate.
Again, it's that collaboration, human and AI working together.
Exactly. And it's working. Allen and Overy seen big improvements in their document review process. Faster, more accurate, and ultimately, that means better outcomes for their clients.
Wow, so we've gone from healthcare to customer service to finance to entertainment to law. It seems like LLMs are really making a difference across all these different fields.
They really are. It's amazing to see the impact that they're having. And it makes you wonder, what's next?
Yeah, what is next for these incredible language machines? Okay, so we've seen how LLMs are already transforming all these industries, but what about the future? What's coming next for these powerful language machines?
The future of LLMs is, well, incredibly exciting. There's so much happening in research. People are constantly pushing those boundaries, new architectures, training techniques, applications.
Yeah, it seems like every day there's a new breakthrough. But one thing that stuck out to me in this guide was the focus on model compression and efficiency. It seems like as these models get more powerful, they also get bigger and require more computing power.
It's a valid concern. I mean, training a massive LLM, it can have a real environmental impact.
Yeah, all those servers churning away, using up energy.
Right. So a lot of research now is focused on making these models smaller and more efficient without losing performance. It's like streamlining a race car. You want to reduce weight and drag, but you still need that speed.
So it's a balancing act. Power versus efficiency. What kind of techniques are they using to achieve that?
Well, there are a few approaches, like pruning, for example. That's like trimming a tree. You remove those unnecessary connections in the neural network, making it more compact.
Okay, so slimming it down.
Exactly. Then there's quantization. That's about using less precise numbers to represent the data, kind of like compressing a file to make it smaller.
It's then a more efficient storage.
Right. And then there's distillation, which is pretty interesting. It involves training a smaller, simpler model to mimic the behavior of a much larger, more complex one.
Oh, so it's like creating a mini-me version of the LLM, but one that's still just as capable.
Exactly. And one of the big benefits of this is that you can run these smaller, more efficient LLMs on devices with less computing power, like smartphones, for example.
Oh, wow. So imagine like having a really powerful LLM right on your phone, doing all that cool stuff, translation, summarization, without even needing an internet connection.
That's the goal. It would open up so many possibilities. And that's just one area of research. Another one that's really exciting is zero-shot and few-shot learning.
Yeah, I read a bit about that. It's basically about teaching LLMs new things with very little training data, right?
Exactly. Instead of needing millions of examples to learn something, you could, ideally, teach it with just a handful.
That's amazing. It would make these models so much more versatile, especially for tasks where it's hard to get labeled data.
Exactly. And it would make them much faster to adapt to new situations and new domains. And then, of course, there are those multimodal models that we talked about earlier, the ones that can handle text, images, audio, all in one.
Yeah, those are the ones that feel like they're straight out of science fiction.
It's true. But they have incredible potential. Imagine a search engine that can not only find relevant text, but also images, videos, audio clips, all related to your query.
Or a virtual assistant that can understand your spoken commands and respond in both spoken and written language.
Right. We're moving towards this world where AI can interact with us in a much richer and more natural way.
It's exciting, but also, I mean, there are potential downsides too, right? As these models get more powerful, we have to be careful about how they're used.
Absolutely. I mean, these are powerful tools, and with any powerful tool, there's potential for misuse. One of the big challenges is ensuring that these models are used ethically.
Yeah, like we've talked about those biases that can creep into the data and how that can affect the model's output.
Exactly. If the data reflects existing biases in society, the model could learn and perpetuate those biases.
So it's not just about the technology, it's about how we use it.
Precisely. We need to be very mindful of the potential for these models to, reinforce harmful stereotypes or create new forms of discrimination.
Yeah, it's a big responsibility. But even with the challenges, the potential benefits are huge. It really feels like we're on the cusp of something incredible with these LLMs.
I think so too. We're really just starting to scratch the surface of what's possible. And who knows what amazing breakthroughs are just around the corner.
Well, that was an amazing deep dive. We started with those simple statistical models, and now we're talking about AI that can write scripts, diagnose diseases, and maybe even someday have a real conversation with us.
It's been an incredible journey exploring this field, and it's clear that LLMs are going to continue to shape our world in profound ways.
It makes you think, what will they be capable of in 5 years, 10 years? It's mind-blowing.
It is, and that's what makes this field so exciting. It's constantly evolving, constantly pushing the boundaries of what we thought was possible.
Well, if you've enjoyed this deep dive into the world of LLMs, be sure to let us know. You can find us on all the usual social media platforms. We love hearing your thoughts and questions.
And until next time, keep exploring, keep learning, and keep wondering about the future of AI.
Thanks for joining us on this incredible adventure. We'll see you next time.